Welcome to qnawire.
Okay, our question says, a car is moving with the speed of 18 meters per second due south at one moment and 27.5 meters per second due east 8 seconds later. Over this time interval, determine the magnitude and direction of A, its average velocity, B, its average acceleration, and C, what is its average speed. Hint, can you determine all of these from the information given? Okay, so I write down here what we were given in the problem, which was that we were given that one of the velocities, which I call, actually I should switch these around because it tells me that initially it's going minus 18 meters per second south, right? So we'll call that V1. V1 is minus 18 meters per second south. South is the minus J hat direction. So that's minus 18 meters per second J hat direction. Then V2, the second velocity is 27.5 meters per second due east, which I call the positive I hat direction. So 27.5 meters per second, the I hat direction. And then T is 8.00 seconds. So maybe I should just go ahead and draw out here the grid we're using. So typically this would be northeast, southwest, but we were calling this I, and this J. Okay. Now, it asks us to A, first determine whether or not it's even possible to find the average velocity, then B, the average acceleration, and then C, it wants us to find the average speed. Okay, and then it says, hint, can these be done? Well, A, the average velocity is displacement divided by elapsed time. And since the displacement is not known, the average velocity cannot be determined. So A cannot be determined. So if we can go ahead and write that for A, we'll just write it out because this would be faster. Cannot be determined. Okay. Now, part B, it wants the average acceleration. Well, we do know that this can be determined because the average acceleration, we'll just call this A average here, A sub A for average is equal to the change in velocity vectors divided by change in time. So delta V, delta T. Okay. Well, this is equal to 27.5 minus 18. And 0.0. And that's in the J hat direction. This is in the I hat direction. Okay. And then all of this is divided by 8.00, which is the change in time that was elapsed. And that's seconds. And this is meters per second. Okay. If you carry this out, you'll find that 27.5 divided by 8 is 3.44. So that's 3.44 in the I hat direction. Plus minus 18, which is plus 18, divided by 8, 2.25. And that is in the J hat direction. The units here are meters per second squared, since this is acceleration. Okay, that's the average. Now it also wants us to not just determine the average, it wants us to determine the magnitude and direction of this average value. Well, the magnitude of A average, A sub A, Now let's rewrite that so it's a little more legible. A sub A is equal to the square root of the square of the values that make it up. So 3.44 squared plus 2.25 squared. Okay. If you carry this out, you get 4.11. 4.11, and that's in meters per second squared since acceleration. Okay. There's the magnitude. And now we also want to find the direction. Well, in order to be able to find this direction, we can use our trig identities where tangent theta is equal to the opposite over the adjacent. And let me draw out the triangle that I'm talking about here. So this is A, right? Magnitude of A, we just determined that. And this is A sub the, let's see, this would be the j hat direction. So this is A sub j. And this is the I hat direction. So this would be A sub I. Okay, so opposite over adjacent for this angle here. This is the angle we want to determine. This is theta. Well, that's going to be 2.25 divided by 3.44. All right, and we want to solve for theta. So if we solve for theta, theta is equal to the inverse tangent of 2.25 divided by 3.44. Three point four. Three. Okay. And if you carry that out, you'll find that the inverse tangent of 2.25 divided by 3.344 is 33.2 degrees. Okay. Well, and that is in the j hat direction relative to the I hat direction. Well, j hat, if you remember, was north, represents north and south, so it's in the positive j hat direction, so it's in the positive north direction, and that's relative to the I hat direction, which is east. So this is north of east. So I just write north for in, or in for north, and e for east, so north of east. Box that in as our direction. Okay, and then the very last thing we are asked to determine was the average speed, right? So C is the average speed. So we will go ahead and get a new page here just for part C, since we ran out of room on the other page. But, however, if you recall, the hint was, can you determine all of these? So the first thing we need to ask ourselves is, can we even determine this? And the answer is no. Since the average speed is distance traveled divided by time elapsed, and the distance traveled is not known, we unfortunately cannot determine this. So even though we started a new page, there's nothing we can do here. So we can write out cannot determine as our solution for part C. And that's it.